Symbolic arguments. This will be the last section of our symbolic logic. A symbolic argument consists of a set of premises and a conclusion. Now we say that an argument is valid when the conclusion necessarily comes from a given set of premises. An argument is invalid, or it's a fallacy, when the conclusion does not necessarily follow from the given set of premises. An argument is like a large if-then statement. If all of the premises are true, then the conclusion must be true. So to check the validity of an argument, we're going to create a truth table. We're going to take all the conditional statements, all of the conditional statement columns. We're going to give columns to all of the premises, and then we'll say that if all of the final conditional statement columns are true, then the argument is valid. If not, it is invalid. So, if I get to the bus on time, then I will be on time to work. I didn't get to the bus on time, therefore I will be late for work. Is that a valid argument? Well, let's see. We'll start by assigning some symbols. We'll let B be the statement I got to the bus on time. We'll let W be I got to work on time. And so the argument we have is if B then W. If I get to the bus on time, then I get to work on time. Not B, I didn't get to the bus on time, therefore not W. The 3 ... is therefore. And then not W. Now to put this into a large compound statement, we're going to say if this and this, then this. And we're going to evaluate that statement. If this and this, then this. And if we evaluate this, and our last column, the argument column, is full of T's, then we know that this is a valid argument. So let's look at some columns. We've got bus work, not bus. So that's the negation of bus. We'll just change the bus column, change its values. Alright, now we need a bus to work column. With these arguments, sometimes a column will get used more than once, so I don't want to scribble out my B column right now. Again, the if-then statement is only false if we have true going to false. So if B is true and W is false, this column will be false. And that only happens here in case 2. Otherwise, this column is all true. Alright, now we're on to our next column. That's going to be looking at these two. And is only true if these are both true. So the not B and B, if B then W. We got a false and a true, so that's false. We got a false and a false, so the and is false. We've got a true and a true, so the and is true. We've got a true and a true, so the and is true. Next we need to look at our last statement, our consequence, not W. So we'll look at our W column and we'll negate that. False, true, false, true. And finally, we'll look at our final argument. So if all of our premises are true, does it necessarily follow that not W? And again, our antecedent, the only case in which this is going to be false is if the antecedent is true and the consequence is false. And that happens right here. So case 3 is false, and all the other cases are true. Since we have four cases, not all 4 of them were true, so this is an invalid argument. It's a fallacy.